Hello everyone and welcome to the Introduction to C# course. This is our first lecture. I am Giuseppe Maggiore and either in some lectures or behind the scenes in order to help me prepare these beautiful materials, Francesco Di Giacomo has also participated in the making of this course. Now, when studying a new language like C#, one of the first questions is, why this particular language? Why are there many different languages? Why do we even have to make a choice, Why can't we just pick the best programming language? And even though there are practitioners around there who will actually claim that there is one best language and accidentally that's the one that they either use or that they know, rest assured, this is never really the case. There is a lot of personal time investment required in order to learn a programming language. It's actually quite common for people to feel deeply invested and have a very strong emotional bias towards the language they want. But let's remove the emotional bias of trying to confirm that the language you spent years learning is the best and you shouldn't learn another one, and look at programming languages objectively. Now, programming languages are a way to turn thoughts, human thoughts, into some formal mathematical logic. And then this formal mathematical logic, with the semantics of the language, has to be turned into an executable program that your computer can actually, take and run. And these two properties, so first, the mathematical part, like how do you turn our fuzzy human language into something that is unambiguous? That's the semantics of the program, like literally, what does each instruction do? But the second bit, how to turn those instructions into something that runs on a computer, well, that influences another very important aspect of our program, namely performance. How fast is it? How much memory does it use? Can it run concurrently, truly concurrently or not, etc. And you can see that some programming languages, such as, for example, Python, or the first versions of JavaScript and PHP, focused on simplicity in the first step of translation at the cost of scalability and performance, because these are still very slow languages. So they use a simplified mathematical model, which on its own is something that has value. But this comes at the price of sacrificing a high-performance translation. Other programming languages, think about C, C++, Rust, they focus on the high performance of applications that must make optimal use of computational hardware, even embedded hardware, without caring about ease of use. So if a feature in the language can make it faster, but is error prone, languages like C, C++, and Rust will go for faster. Because if you're thinking about an embedded application that has to run on Arduino, yeah, how easy it was to write the code for the software developer doesn't really matter that much. Other languages, think about Haskell or F#, they focus on preventing bugs through mathematical models, again at the cost of ease of use. So basically you have the error proneness of the language, how easy it is to write code with bugs, the ease of use, how easy it is to write code without worrying about weird stuff, and you have the performance. And usually you can pick usually you can pick 1.5 of these properties. That's not entirely true though. And every programming language will strike a different trade-off between ease of use, performance, reliability, etc. And obviously every language will focus on an operating system or an environment where it runs optimally. Again, for example, JavaScript mostly in the browser, even though we have Node.js, PHP mostly, well, in the backend, and so on. So how about C#? C# is, first of all, a relatively old language. It's 20 plus years old at the time of recording this lecture. It did start as Microsoft's Java. And just like Java, The syntax of C# was heavily inspired by the syntax of C and C++, and just like Java, it started off with objects and classes as first-class citizens. It features memory safety through garbage collection, meaning that we don't need to worry about things that are not used anymore to be cleaned up from memory by us. Whereas in C++, you have to actually track which objects need to be cleaned up, otherwise you run out of memory, etc. So basically, C# started off as it was just Java with some C++ influences. But the C++ influences were actually heavier than you could see on the surface. C# received a very strong focus on low-level performance. And this made it accidentally very successful in, well, of course, Windows and Microsoft programming, because people were fed up with building Windows Form applications in C++. It was a nightmare. And video game development through the Unity 3D engine. I personally find that Unity 3D has been one of the things that has pushed C# to being so beloved, with the Mono framework, which was the first attempt at an open source framework for running C# code. And indeed, this Unity version of C#, Unity 3D, this video game engine, caused a huge interest that kept showing Microsoft, come on, open source is important. And eventually, after God knows how many years, well, you can just Google how many years actually, Microsoft open sourced not only the language, because the language was already open source, but what's an open source language specification if you don't have an open source runtime? And Microsoft released .NET Core, which slowly but steadily turned into .NET 6, where finally there is no difference between the Windows-centric proprietary version and the one that runs natively on Linux and Mac, capable of supporting web applications, running on any operating systems, etc. So this is, let's say, the technological aspect and the open source aspect. And yet, there is a bit more. C# has been innovating very fast as a language. C# has a partnership with the F# language. F# is where most of the innovation in programming languages is translated directly. So F# is a very advanced programming language. And C# has picked the most interesting bits of F# and integrated them in the language. For example, LINQ queries, which have actually been a revolution when it comes to writing type-safe, IntelliSense-friendly queries that translate seamlessly back and forth to SQL. But also async await and the task parallel library have actually inspired many similar language features in other languages, like JavaScript, TypeScript, and a lot more. So async await really started off and was popularized by C#. Lambdas, tuples, records, they took inspiration from functional programming languages, but they translated it in such a way to bring it to the mainstream, and we actually see it more and more, limited type inference, etc. In short, C# has been at the forefront, no, not at the forefront, just one step behind programming language innovation for 2 decades, bringing advancement in a pragmatic and useful way, and inspiring many others. And so where C# started as just a sad imitation of Java for Microsoft, it now has a full identity, and I do personally believe it has absolutely surpassed its original inspirator by being a pragmatic, useful, industry-grade language, which features all of the advanced functional programming and advanced programming language constructs in an elegant, useful, and pragmatic way. Theoretically sound, pragmatically useful. That is what makes C# powerful and what makes it absolutely beloved by so many developers. Let's set up our dev machine. First, I'm assuming that you're going to install the .NET SDK first. For this, please Google. I assume that you have installed Visual Studio Code, and if you're running on Windows, well, please make sure that you have a WSL terminal. I'm assuming you have a terminal and not the Windows PowerShell terminal, or even worse, the Windows command line. Most hosting platforms are based on Linux or Docker anyway, so you just bite the bullet and learn how to work with Linux or even WSL, which is basically Linux embedded in Windows. Let's open Visual Studio. Let me delete everything. Okay, let's create a new project. By typing .NET new, let's make this a little bit bigger. Okay, we get a lot of examples of templates that we can create. We can create an ASP.NET Core web app or Blazor server app, etc. But the only thing we really need is a console application. Notice that .NET is not a synonym with C#. C# is the default, hence the square brackets, but you can also create a console application in F# or Visual Basic.NET. And do not diss Visual Basic.NET, it's actually quite a nice language. Obviously, we're going to work with C#, so we type .NET new console, and what do we get? We get, as you can see, a CSproj file based on .NET 7. It will produce an executable and a couple of nice features of the language. And we have program.cs. Here we are. By running .NET run, well, this is the first time we run this program, so it needs to be compiled, etc. Okay, and we get hello world. Very good. I will start the compiler in watch mode. So .NET watch build will wait for any changes and then recompile the program. I'm going to save, and you can see as soon as I save the file, the program gets recompiled. And in another terminal, .NET run, and there you go. Now you can see the 3 exclamation marks. You can see some folders here, obj and bin. Bin contains the final release, yes, the final release of our program. And there are 2 folders in bin, debug and release, depending on what kind of compilation you have. In debug, you get a slightly bigger executable. The executable is here, it's the DLL. In debug, you also get all the information for debugging, so that's the PDB file, plus other, well, configured dependencies and yeah, for which runtime is this, and is this DLL built, etc. You might also get another folder, which is the release folder, and the release folder will contain, well, a slightly more optimized compiled DLL. All the intermediate compilation artifacts are found in the obj folder. So if you wanted to give someone your program in a way that they can more or less run it, you have to give them the bin folder, and that's enough. And in the obj folder we find, well, for example, in the cache of NuGet, so the dependency packages that are stored here so that you don't need to re-download them every time you compile, and so on. We're going to ignore this. It doesn't really matter that much for us, but well, just know that this thing is here. Let me also put a breakpoint here. Let's generate the C# assets for debugging. Okay, so the breakpoint, you see I just clicked here, and now we press this button. And quite impressively, actually, that this works out of the box in Visual Studio Code. This is a very Visual Studio style experience. And you can see now that the program has stopped here. And this allows us to inspect memory, to run the program one instruction at a time, and so on. This is extremely useful. We will use it a lot. All right. Now, C# is obviously based on the very standard imperative model of instructions and state. Instructions are the code we write, and they do two main things. They, well, control the flow, so instructions might simply pick which instruction needs to be evaluated next. When we have conditionals or loops, the instructions of conditionals and loops make decisions about, okay, what to do next, and especially what not to do next. So they skip stuff and select stuff. And obviously, other instructions will read or write data from and to the state. And in a sense, the state keeps track of all the structured information needed by our program. But structured information is not just strict data that maps to almost physical real-world data. It could be which processes are running at the moment, which users are logged in, but also name, age, and address of a user, and so on. And the instructions define the thinking process that our program represents in general in order to elaborate and transform the information stored in the state. And so we have state at time 0, plus the first instruction 0. This gives us state 1, and then the instruction 0. So the instruction 0, basically, what does it do? It takes the current state and it produces a new state, but the instruction also says, okay, and that's the next instruction you have to run, and then we get another state and another next instruction. Let's be consistent, and so on. Understanding programming, especially in C#, but in most programming language, means understanding the infinite sequence of states and instructions. And it's infinite. That's what makes it really tough. And obviously there are some, well, not everything changes in the state, so S0 and S1 are usually identical minus a couple of variables or some very small things that have changed. So these changes are tiny, and these changes have sort of trajectories. So they move in a way that is slowish and consistent. And if you think about it, what we really care about is that the state of our program makes sense. So everything our programs do involves transforming the state in a reasonable way, in the way we need, according to the domain of the program. The state of the program is stored in memory, but also sometimes it goes from memory to permanent storage, such as files, an external database, or even an external system via an API call. But we will focus on memory throughout this whole course. And the state, what does it look like? Well, the state is basically a big object containing... Oh, wait. Yes, I want to indent using spaces, come on. With two spaces. Yes, I'm not judging, I use two spaces. You may use whatever you want. And even if you're a monster and you want to indent with 7 spaces, I don't judge, but I use two. I like the compactness if you want. Okay, so we could have, we will have a state, which could be name Giuseppe Maggiore, age is 38, address, well, we can also have nested objects. So street is Balaton Merlan, number is 21, and so on, you know. So this is what our state of memory will look like, a nested tree, but sometimes there might even be references. So there might be elements that point at each other. So if it's not really a tree, because if you follow the references, you might end up having cycles, and well, that's actually quite rich and quite interesting. We will see more of the state throughout the whole course, but for now, that's enough as an introduction. So, in this course, we are going to deep dive quite intensively into C#. We're going to see variables, primitive types, and expressions in the next lecture. Then, the lesson after, we will look into conditionals, the things that allow us to make decisions. Then we will talk about loops, for, while, and do while. Then we will discuss functions and a special area of our state and memory, which is called the stack. Then we will talk about arrays and a gigantic and very representationally rich area of memory, which is called the heap, for big and complex data structures. Then we will look into how to build custom types, mostly with tuples and records, which are very clean and very simple for the beginning. Then we will talk about object orientation and polymorphism, because C# is born for this, and these are the advanced constructs, you could say. We will close off by looking first at handling errors and exceptions, because in programs we don't always get the happy path because of validation issues, etc. So we will look into how to graciously manage all of those unhappy paths. And finally, the cherry on top will be our discussion on generics, where we will see how to build advanced modularized software. Every lesson comes equipped with a practicum. Every chapter comes equipped with a practicum, and in the practicum we do a series of guided exercises where I will show how to solve the exercises on screen, and you are kindly invited to follow along. I hope this first introduction has been interesting enough. Thank you very much for listening. The best of luck with learning this wonderful and very powerful and very useful language, which is C#, and see you soon. Bye bye.